Morning students, here you can see in the glass of water I have taken. Here I have placed the pen, the blue color pen I have placed, and here you can see there is a difference. So when I take the pen in my hand, you can it is in normally we see that the pen is straight, but here you can see at the inside the water, the portion of the pen which is inside the water, it is slightly different. Means that in the change of path, that direction of the pen is slightly different than the top of the part. So why it happens, we will be discussing now.
As you have seen in the previous that short clip, there I have tried to show you in a glass of water how the pen was kept and how we have seen the different images or the reflection of the light. So here we will be discussing about the reflection mainly. So if in that one we have seen that, one second. So we had taken a glass of water, and in the glass of water we have placed the pen like that. So here you can see the pen is like a straight pen, but in that short video clip there we have seen that the portion of the pen which is above the water is in one direction, and after the water, or the portion of the pen which is dipped into the water is slightly different. The direction of the pen was slightly different than the top one. So there was something. So this is one type of phenomena of light, and that is known as refraction of light. So previously we have discussed about reflection. Here it is refraction. So it is very important and very interesting phenomena. So what is reflection? So there are two different mediums. So when two different mediums are there, or optically dense or optically less mediums are there, when two different different mediums are there, like one is there air. So above the water, that medium is air, and in the water it is the medium is water. So we all know that the density of air is less than the water, and the density of water is higher in compared to the air. Simply we, all of us know that. So when two different mediums interact, so there is a something happens, and that is known as refraction. So one light ray when travels straight and hits or intersects in another medium, the light ray slightly bends, or the path of the light ray changes. So this phenomenon of light is known as refraction of light. So when a light ray travels from one medium and enters another medium, the light ray changes its path. The path of the light ray changes when it enters another medium. It may be optically denser or optically lighter. So it happens in both the case, whether it is moving from a denser medium to rarer medium, or rarer medium to denser medium. So in both the cases it happens. So it is known as refraction. So once again I will repeat, when a light ray travels from one medium and enters another medium, the path of the light ray changes slightly, and this phenomenon of light is known as refraction of light. So there are two laws of reflection. As the laws of reflection, there are two laws of reflection. And what are these? These are incident ray, refracted ray, and the normal at the point of incidence of two different media all lie on the same plane. Means the incident ray, the refracted ray, and the point of incidence, where the two different mediums are there and the point of incidence, there one normal will be there, imaginary normal, and all these three things, there is incident ray, refracted ray, and the normal at the point of incidence of two different medium, all these three lines lie on the same plane. And the second law is the ratio of sine of angle of incidence to the sine of angle of refraction is always constant for a given pair of media. So incident ray will be there, and there will be our imaginary normal. So there one angle will be there. This is known as angle of incidence. We all know that. And this is our refracted ray, and this is our normal. So there will another angle between the refracted ray and the normal. This angle is known as angle of refraction. So sine of angle of incidence means, in your general mathematics you will get the things like the angle value will be there, and along with that sine value will be there. So in trigonometry you will get those terms, sine, cos, tan, and all. So sine of angle of incidence, so consider this angle is 45 degree. So the sine 45 degree and sine, that angle will be different. In case of reflection, we have seen that incidence ray and in the incident angle and in reflected angle were same, but in this reflection it will not be same, it will be different. So these two, the value of the sine of angle of incidence and sine of angle of reflection, consider this is 45 degree and consider this is 30 degree. So we will put the value sine 45 and sine 30 degree. So there will be values of these ones, sine 45 and sine 30, and when we will divide this we will get a constant. So in this given pair of medium, air and water, it will always be same. So that angle if 45, consider now we have changed it to angle 60 degree, and because of this 60 degree it will change, consider up to in 20 degrees 20 degree. So in that case also it will be sine 60 and sine 20, that value will all be same. Consider this 45 and 30, the value is 1, consider. So similarly for 60 and 20 it will also be 1, consider it is 80 degree and it is 10 degree, that will also be 1. So in given pair of medium, air and water, if it is air and water always, that value will always be same whether the angle is whatever the angle. So it does not depend on the angle. If the two mediums are same, the constant will be same. So this is known as Snell's law. One scientist was there, his name was Snell, and he discovered these things, that's why it is known as Snell's law. Okay, so next we will move to refractive index, very important. Once again. Okay, so refractive index. So what is refractive index? So we get a value when we divide the sine of angle of incidence to that sine of angle of refraction, we get a value of constant, and that is marked with n or symbolized with n. So it is known as refractive index. So it is very important, and it is related to the speed of light in different media. So why we get first thing comes in our mind, then when a light ray travels from one medium to another optically denser medium or rarer medium, why the light ray changes its path? Because in a dense medium the light cannot, or I can say that light do not travel in same speed in all the mediums. So if it travels in air at one speed, it will not travel in water at the same speed. So the speed of the water, that light will be different in different mediums. So the more dense the medium will be, the light ray will travels less fast, means it will be travel very slowly. So consider here we have vacuum, air, water, glass and diamond. So in diamond the light ray will travel very slow in compared to this vacuum, air and water. So in air it will travel little fast than water, means the density of the substance will determine the speed of the light of the in that medium. So if the medium is dense, the light will travel slow, and if the medium is rare, optically very less, the light ray will travel very fast. So it is related to speed of light in different medium. So this refractive index. Okay. So here we have taken three different cases. One, we have taken a glass of water, another piece of glass, so it is glass, you remember, and it is a diamond. So I have just tried to draw one simple diagram of diamond. So these three cases I have taken. So in a glass of water, so the light ray was traveling, and at the point of incidence, this is the meeting point of two different mediums, and from that point the light ray is changing its path. Similarly here in the glass also the light ray was coming, and at the point of incidence of these two different mediums, the light ray changes its path. And similarly here also in the diamond also the light ray has changed. But here you can see three different things. Here the light ray changes slightly, here it has changed little more, and in the diamond it has changed very fast, very more. Why? Because it is more dense than glass, and glass is more dense than water. So it is, if it is more dense, then the light will travel slow, and we can see more deflection in the medium. Okay, so how do we find out the refractive index? For that one we have a formula, that is n, you can write it like this, n to 1. So what is 2 and what is 1? So 2 is that it is the refractive index of the second medium in respect to this first medium. So here consider this, in the case 1, from the air the light was coming into the water. So what is the refractive index of water? So we will find out like this, NWA. So W will be our water and A will be air. So speed of light in air, so this is the medium in the air, and with respect to this air, the speed of light of water, so there is water will be here, so that value will be the refractive index of water. Okay, so the which one we are finding out, we need to write it first W and the second one. Similarly here the second and first. So here in the second case we have seen from the air it is coming. So speed of light in air to the speed of light in glass. So this is the refractive index NGA, that is the refractive index of glass with respect to air. Similarly in the diamond, sorry, it should be a diamond. So what is the refractive index of diamond? That is the speed of light in air, the speed of light in diamond. So this is the that value will be the refractive index of diamond with respect to air. With respect to air, the refractive index of diamond will be like that. We have to find it. So what is another topic? Topic is the very important, that is absolute refractive index. What is this? So absolute refractive index is very simple. It is like a refractive index, but here that with respect to what, it should be fixed. So in these cases it may be diamond to glass or water to glass, and it may be anything. But in absolute refractive index, the first medium, it should always be air or vacuum. So if it is air or vacuum, then the refractive index will be known as absolute refractive index. So consider these three are absolute refractive index, because the water, glass and air, the first medium is always air. So in that case, the value of the refractive index of water will be 1.33. So in this case, in water, the refractive index is 1.833, and in case of glass, the refractive index is 1.52, and in case of diamond, the refractive index is 2.42. So in your book, one table is given, you can learn it by heart. So different refractive indexes or absolute refractive indexes of different mediums are given with respect to air. So with respect to air, the refractive index is 1.33. In case in respect to air, it will be 1, because the refractive speed of light in air, the speed of light in air, in both the cases, with respect to air, the speed of light in air, it will be 1 by cancelling the two things. Okay. So this is about absolute refractive index. So here you can see, if it is more dense, the refractive index is more. If it is less dense, the refractive index is less. So in compared to here, I have written like in vacuum, the refractive index will be 2 less. In air, it will be little more. In water, it will be little more. In glass, it is slightly more. In diamond, it will be more. So here you see 1, 1.30, 1.52, 2.42. So it is increasing slightly. Light will travel slow, but refractive index will be more. Okay, so this is all about refractive index and absolute refractive index. I hope up to this much clear. If you have any kind of confusion or any doubt, you can directly ask me. And thank you for watching the video.